Hi, my name is Arnab Mitra. I'm a Premier Field Engineer at Microsoft. This session is about the recent changes in the boundary groups introduced in ConfigMgr Current Branch 1610 release. So we will be talking about the reasons for this change and why the new model was adopted. We will discuss the new relationship model and its workflow. We'll also talk about the boundary group changes post the 1610 upgrade and also take a quick look at the deployment changes for the applications and packages. So talking about the old boundary group, or existing in case you haven't upgraded to 1610 yet, it was complex as there were way too many configuration settings controlling the whole fallback behavior. Here are some screenshots. As you can see, we start with the distribution point properties to allow fallback behavior for the clients to download the content. In the boundary group, you can set the site systems as slow or fast, and then finally at the deployment type, which could be MSI or EXE, you're controlling the behavior to execute the program depending on the type of network it is. And then once again in the deployment properties, you choose whether you want to allow fallback and the deployment options for slow and fast network, which is kind of redundant. You can expect to get the desired results only if you have configured the right settings in all four places. And even after making all these changes, one of the biggest challenges is the lack of control on the fallback behavior. Another problem is the slow and fast DPs being part of the same group. You cannot really divide them and have a better control on it. You don't have a named home for unprotected distribution points. So we talked about the challenges. Now let's see what 1610 has to offer as a solution. Relationships is introduced as a new tab in the boundary group properties. Here you define the fallback relations with other boundary groups which are called neighbors. This gives you control over fallback by defining the precedence, which is a timeout value in minutes. A neighbor boundary group, which is closer to the client, can be configured for a smaller timeout value when compared to a boundary group which is further away on a WAN link. Instead of randomly picking up a DP from its fallback like in the previous versions you have seen, in this process, when the client cannot find content in the current boundary group, it will fall to its closest neighbor based on the timeout value and download the content if it's available. Overall, this gives a better control on a fallback and achieve the desired results. Let's look at the workflow of this new model. So we have a company who have an office in New York with two distribution points. If a client is requesting for a content, it randomly selects one of the distribution points in its current boundary group, which could be DP1 or DP2 in this case. What if the content isn't available on that DP? Well, within 2 minutes, it will switch to the next distribution point in its current boundary group. This is a change in behavior from previous versions when it used to wait for 120 minutes before making a switch until it reaches the last distribution point in its current boundary group. This makes the whole content lookup process much faster. So if the content isn't available on any of the distribution points in its current boundary group, now it will look into the relationship table where the fallback behavior is defined based on the timeout values. The closest neighbor based on the timeout value 30 minutes is the Chicago office. So the clients will wait for 30 minutes and then try to look for the content randomly either in DP3 or in 4. Once again, the switch between the two DPs is 2 minutes until it reaches the last distribution points in its neighborhood boundary group. What if the content isn't available in the Chicago office either? It will check back in the relations table and based on its timeout configuration, look at the next neighbor, which is the Seattle distribution point 5 and 6. The same content lookup strategy applies to all neighbor boundary groups until it reaches the last boundary group before starting over the process from the current boundary group. When the client is part of multiple boundary groups, say overlapping boundaries, which is supported for content distribution, the end result in that scenario will be a union of all the boundary groups, which will really expand the list of available neighbors and more distribution points to look for the content. There is also the concept of the default site boundary group, which is an addition to the neighbors you define. It's an implied link created automatically connecting to each boundary group with a timeout value of 120 minutes, but it's customizable. When the content is not available anywhere else, the client can fall back to the default site boundary group. Or in a scenario, if a client is not part of any boundary group, it can seek content from the site default boundary group. If you don't want the client to fall back to its default site boundary group, you can configure it to never fall back. This is an available option.
Now let's look at the upgrade scenario when you're moving to 1610. In this example, I have two boundary groups, East and Central, both with site systems slow and fast. When you upgrade to 1610, configuration changes are made automatically to adapt the existing boundary groups to the new model. To begin with, a default site boundary group with site code is created for each primary site in a hierarchy. We already talked about its role as a fallback for content distribution, and as you can see here, the option to add any boundaries on this boundary group is disabled. Next, the distribution points with allow fallback option checked, and the state migration points are added to this group. Typically, all distribution points have this box checked, allow fallback for source location, unless it's explicitly removed. It remains the case in my scenario, so I have both the DPs listed in the new default site boundary group with my site code PS1. You will also notice the site assignment is checked, but it's not really a concern since it does not allow any boundaries to be added. Moving next, if you have site systems configured as slow connection, which is also true in our case, a new boundary group is created, which is named like the original boundary group name hyphen the boundary group ID. The value boundary group ID is really hidden from the console and can be viewed from the database table named boundary group. All these slow connection site systems will be copied to this new boundary group. They are also left in the original boundary group for a backward compatibility, but they're really hidden from the console view. So as you can see in the screenshot, before upgrade, I had my domain controller 1 in boundary group East configured as slow. Post upgrade, it's added to the new boundary group created for the slow site systems. Finally, this new boundary group for slow site systems will have a fallback link to its original boundary group East with a fallback time of 0. So I started with two boundary groups, East and Central, before upgrading my site to 1610, and post-upgrade I have three additional boundary groups. The default site boundary group and the two boundary group with IDs for site systems which were marked as slow on each boundary group. If you also notice, the site system count for the boundary group East and Central still say 2. However, they only have one site system in the screenshot as you see. The hidden item is the slow site system for backward compatibility, which is now added as a relationship as a neighbor boundary group with the default timeout of 0 minutes.
To see the complete picture, let's look at the upgrade workflow in this slide. Before 1610, you have boundary groups like 1, 2, and 3, And you would also have various flavors of distribution points, management points configured as fast or slow. Some are shared with a state migration point role, and say some are not configured for a fallback. These site systems are connected to boundary groups 1, 2, and 3. And once we upgrade our infrastructure to 1610, we see the original boundary groups, as well as there is an introduction of the default site boundary group with the site code. Now, distribution points, which are configured to fallback, and the state migration points are copied to this new group, except the ones which are not configured for fallback or configured as slow. These site systems would still be part of their original boundary groups, with the exception of slow site systems. Next, we have a new boundary group for slow site systems called the original boundary group name with the boundary group ID. The slow site systems are copied to this group. The dotted lines are suggesting the relationship of the slow boundary group with their original boundary group as their neighbors. I hope this workflow provided a better understanding of the changes. There are changes specific to boundary groups created in secondary site. These changes are similar to slow site systems, with the only difference being the name, which will be called secondary site neighbor-temp with the site code. The distribution points with the allow fallback source location checked and the state migration points are added to this group. And finally, a fallback link is created between this new boundary group and the original boundary group in the relations as a neighbor with a default time set to 0 minutes, similar to the slow boundary group system. Now let's look at the changes for deployment in the application model. It's simplified now with just two options to select from. Under the properties of the deployment type, which could be an MSI and EXE, in the Content tab, we have these highlighted options. The first is whether you'd like the clients to use the distribution points from the default site boundary group. Checking this option is going to expand the pool of available distribution points for the client. And then we have the deployment options to either let it download from a neighbor and run locally. The neighbors are already defined in the boundary group relationships. Or the other option is do not download the content for cases when you don't want the client to look for the contents for any of its neighbor and wait for it to be available in a local distribution point. It can be applicable for large size contents like Office where you cannot afford to choke the WAN bandwidth. Next is the legacy package model. The fallback changes are visible in the deployment properties under the distribution point tab. Here you specify whether you want to let the clients download package from neighbor boundary groups. Checking the box increases the pool of available distribution points. We also have the deployment options matching similar to the application model where you specify to either not run or download and run locally. To summarize, the new boundary group model makes the overall administration simple and easier to manage the content fallback in a controlled manner. This concludes the session. Thank you for your time.